Join me in welcoming our moderator, who I know is going to do a great job. We just had a great chance to chat a few moments ago, and we're going to be talking about innovation in clean energy. Please welcome up Dr. Susan Powers. I'll have you just kind of come right over here. So Dr. Powers is from Clarkson University, the Spence Professor for Sustainable Environmental Systems and the Director for the Institute for Sustainable Environment. Now, the panelists are coming up here, and you can just come on up as I call your name. These folks are leaders in the field of clean energy, and they include, and please come on up, Dr. David Sandbank, Vice President of Distributed Energy Resources. Thank you. Welcome. And he oversees New York State Energy Storage and Clean Transportation for New York State's Energy Research and Development Authority. Afternoon. Mr. Tyler Horton is the President and CEO of Lion Energy. Come on up, Tyler. See you again. And Professor Ken Visser, representing ducted wind turbines and Clarkson University. Come on up. Good afternoon. And finally, Pete Rose, Director of Stakeholder Relations with Hydro-Quebec. Good afternoon. All righty.
All right, thank you. So it's a pleasure to be here, and I have to admit we've sort of changed our approach after hearing all the great talks this morning. So it's an interesting to come and to interface, and so much that we learned this morning. So I just want to say I am an engineer, and I am technical in nature, and I think one of the things that we heard this morning are how important climate stories are, and the impacts on people, and the fact that our climate is changing, and it is having an impact on our winter sports and many, many other things. But it also has to have technical solutions. And so sometimes the technical solutions are a little less friendly storytelling, but I think it's important to understand sort of the basis of what our clean energy future is going to look like. So in this session, we're going to do sort of a two-part. I really want to start with what does a clean energy system look like? And we're really going to talk about energy or electricity, especially electricity in New York State. You heard the great introduction this morning about New York State's climate law, the Climate Leadership and Community Protection Act. The second scoping document just came out last month. So we have David Sandberg, who is going to talk about that. He's from NYSERDA, and he has a really good big picture of that. So we're going to talk about the technical solutions. I also just want to add to our introduction, in addition to David, who is from NYSERDA, we have Peter, who is from Hydro-Quebec, and we heard a brief introduction about how important Hydro-Quebec's contribution is to New York State's clean energy future. Ken Visser from Clarkson did all of his research and has developed a small ducted wind turbine. This ducted wind turbine is actually powering the torch. So the torch this year for the games is not a flame run on natural gas or propane. It's LED lights fueled and powered by Ken's ducted wind turbine. So he has a great connection there, and it's a great success story of innovation. And Tyler's batteries, Lion Energy does batteries, small batteries. His batteries are across the games. At many venues, they are being charged and then using, especially for some of the remote locations, to provide clean power. So rather than having a dirty diesel or a gas generator, we've got batteries operating many of the venues. And so you can see we've got a great panel here with a lot of experience with clean energy, and especially on electricity. So this morning we heard about New York State's goals and the fact that we are a leader. New York State government is a leader in regulations and legislation for clean energy. It includes clean electricity, transportation, and all sorts of other activities. One of the things that I want you to remember is that clean energy is a big system, and everything is interconnected. Clean energy includes efficiency and conservation. That means turning off your lights when you don't need them. It means using LED light bulbs instead of incandescent light bulbs. That's efficiency. It also means electrification. And that means transitioning from some of our fossil fuel, like natural gas heat, or gasoline-powered transportation, to battery-powered and electric-powered heat pumps, so that we can use the clean energy, clean electricity that we're making, that we can use that instead of fossil fuels for things like transportation and building heat. But that's going to cause an increase in the electricity demand. And so we also have to think about how do we make that electricity. And so the third word, we had efficiency, electrification. The third word is decarbonization. What do we have to do to rely less on fossil fuels, so to decarbonize, and more on renewable resources and storage to run our electricity system? All of those are part of the energy system. So we're going to start talking a little bit about the technical aspects of this, and then we're going to move into the people side, because we totally believe in the importance of society and the people side of things. So including education, information, not in my backyard, all of those are part of the energy system as well. So let's start thinking about, what does this system look like? David has the best overall big picture understanding from his work at NYSERDA. He has a lot of experience with solar and transportation systems. Can you give us a sort of a big picture idea of what New York State's electric system is going to look like in the next 10 and 20 years?
Sure, and thanks, Susan. I appreciate it. And right before that, I just want to sort of get into the why first, because I'm looking into the audience. I see a lot of people that are younger than I am, and I'm just wondering, from a show of hands, how many people think that the environment is the #1 issue facing your future? Okay, don't feel pressured to raise your hand. And it's really important, because we only have a certain amount of time to address our environmental situation that we're in right now, and we have to act upon that. It's, in my opinion, the biggest challenge to modern mankind that we're facing. And so that is, the why. We need to do something about it. In New York State, to Susan's point, we are really being proactive compared to many other states and many other countries in what our goals are. Our goals in New York State are incredibly aggressive, and for a really good reason. We have the Climate Act, right? It's a legislative mandate that we have to have our electricity produced, 70% of it needs to be produced by zero emission sources by 2030, and 100% zero emission free by 2040. And we have to reduce our greenhouse gas emissions 40% below 1990 levels by 2030, and 85% below 1990 levels by 2050. So that means we have to do a lot of what Susan was talking about: electrification of transportation, electrification of heat instead of using fuel for both of those. And then we have to put a lot of renewables on the grid. And by putting renewables on the grid, we're going to transition from what we call a single power plant source that's probably running mostly on natural gas or oil, that runs through a lot of wires all over the place throughout the state to get the power from where it's generated to where it's needed, to more of what we call a distributed energy resource plant. And that's where we take smaller, different technologies and place them around the state, so we don't have to move the electricity around as much. It becomes a much more stable way of doing it, much more diversified amongst technologies and locations and times at which that could produce zero emission electricity. So we're talking about solar, we're talking about wind, hydro, and then some nuclear. But really what happens is, once we take all those renewable energy sources onto the grid, what they do provide is intermittent power, right? The wind blows and it turns the turbines, and then that creates electricity mostly at night. During the winter, solar only produces power when the sun is shining. So what happens, in between there, we have to really have energy storage. And so what now the governor has just approved, and we just submitted this roadmap for 6 gigawatts of energy storage to be put on the grid by 2030 to accompany all the renewable and intermittent technologies that are going to be supplying carbon-free electricity. So what we're doing, we're in the middle of a transformation, as Susan said, weaning ourselves off fossil fuel for our cars, for our heating, and we're also going to increase our production of electricity through renewables, which has an intermittency to its production. So we have to add firming capacity, which they call it, which is going to be batteries and hydrogen, and other technologies that don't even exist currently, but will in the future. So, basically, long story short, we're going to have to completely transform the way our grid behaves in a short period of time if we're going to address this environmental impact that's coming our way.
Thank you, David. Ken, can you speak just for a minute on the role of wind? You have experience with small wind, but also you know an awful lot about the big wind as well. So what are the roles there in our clean energy future?
Thanks, Susan. Yes. Well, obviously, wind will play a significant role. And if you've been following the news, New York State is investing heavily in offshore wind. I think there's 2 plants now that have been commissioned, and there's maybe 3 more. David would know more about that exactly. But essentially, they're taking a big step to using that as a renewable energy source. Of course, the problem is it's a transient source. And so that has to be integrated appropriately. Most of my work has been done on small wind, also distributed, like what David is saying, but not a smaller plant distributed, almost distributed to the individual owner type of level, which is really another smaller set. And that really has to be accommodated as well, because as we move towards electrification, people will realize that I can actually generate my own power at my home. And whether it's wind, a lot of people ask me, should I have wind or solar? I tell people you should have wind and solar, quite frankly. You will see more people adopting that, not just because it's the thing to do. I think there's an economic driver that comes with this as well, and as we move to electrification of transportation is a very good example. People will be able to realize I can generate my own transportation fuel at my home. And I don't have to go down the street and pay for some sort of fuel that is beyond my control, some sort of price. And so when that American or that conscious shift occurs, you're going to see a huge uptake in people wanting to move towards electrical generation at that distributed level, at their home or their business even, something along that line.
Great, thank you, Ken. Tyler, it's a great segue into your role and Lion Energy's role in terms of the batteries and the role of batteries both at the sort of grid level and the home level in this sort of integrated future grid.
Awesome, yeah. I appreciate David's description because the solution is not, a lot of times we try to look for one solution and there's not one size fits all in this situation. Energy storage is so critical both on the utility side of the equation and also on the consumer side. And all of you have the opportunity to think about how you use energy in your life. And energy storage allows you to bring the energy with you. As Susan described earlier, we're bringing energy from where it's delivered to where the athletes need to use it here in these games. And energy storage is just so powerful on both the distribution and also on transmission and also on the technology side and being able to understand more about what energy you're using. For the accountants out there, the grid is really kind of a just-in-time delivery of energy. And in order to have inventory of energy, to have storage, you have to have the storage there to be able to deliver it when you need it and where you need it. So.
Thank you. And Peter, so we heard a little bit this morning about the importance of Hydro-Quebec's Champlain Hudson Power Express. And hydro has had a long, important role in New York State, and this brings us even more hydropower into the state. Can you tell us a little bit about that big project that you have, but also in general, the role of hydropower overall in our state clean energy future?
Sure, thank you. Is this working? Can you hear me? Perfect. Happy to be here. Happy to see so many faces that I know and new faces as well. Hope everybody had a nice lunch. Everybody good? And I think what's positive I've heard so far on this panel is that the technologies exist, right? I mean, the technologies exist that we do not need to depend solely on fossil fuels. I think that's important. I think there's a lot of misinformation out there saying that, you know, life as we know it, the economy, our everyday life will come to a screeching halt if we make this transition. This transition is going to be long, it's going to be costly, it's going to be difficult, but we have the tools to do it. So I think for the young people in the room here, be empowered by the fact that the technologies exist, that the policies are pushing in the right direction, and that you can be part of this solution as well. All these technologies are wonderful. They all have different characteristics. Hydropower, in the simplest form, is just using kinetic energy. It's the power of water. So from rivers, turning turbines, which will generate electricity and deliver it over transmission and distribution lines. And this is power that is continuously being produced. So the water is flowing, turning a turbine, it's not stopping. We went back to David's a comment about intermittent and firming and base load powers. This is where we start getting into some of the wonkiness of it. You have wonderful technologies like solar and wind. You need something that's going to provide that power when those wonderful technologies, because of Mother Nature, are just not producing. So we all have to work together. The batteries as well. Batteries are wonderful. Batteries have a certain life, right? And we're improving technologies. So we have our phones. We look at our phones. I got to charge it up. We have short-term battery storage now. Long-term duration storage can come in many forms. It's going to advance in batteries, but hydro can also be used for, and I can talk about that a little bit later. So I wanted to just touch on the fact that I think we should all be reassured that we have the technologies, we have the momentum, I think, we have the support of leadership, and we should seize this moment, and I think the young folks in this audience hopefully will be inspired by what's happening this week. The Champlain Hudson Power Express is a new transmission line. So we talk about getting power to places, right? It's wonderful to say I'm going to produce the power in one spot, but you have to deliver it somewhere, right? So you have to, there is infrastructure. Infrastructure is not necessarily something that we think about every day. We depend on it. We go, we take bridges and roads, but we really don't care how it looks. It's not really sexy or fun, but it's necessary, right? So Champlain Hudson is a long piece of infrastructure. It's 340 miles that goes from the Canadian border all the way into New York City. That will be buried, so it will go underground and it will go underwater. Very advanced technology, and I can get into later, as we talked about social acceptability, what we needed to do to get this project done. And what it will deliver is this continuous power to New York City. Now we're in the North Country now in Lake Placid. We heard from Basil Sagos this morning how blessed we are to have, 80% of the power up here is renewables and clean. A lot of it's coming from Hydro-Quebec, from NYPA, from other sources, from nuclear power. New York City is the complete opposite. It's where I live. So it's 90% fossil generation in New York City. And so in order to be equitable across the state, we need to make sure that we're getting power from the offshore wind, from the solar, and from hydro into the load centers or the areas where people are consuming it, where they're depending on fossil fuels. So that's what this project's going to address. Addressing displacing fossil fuels so people do not have to breathe in the air pollution that's a byproduct of burning fossil fuels.
If I could just add something really quick. Why that's so important is because if you think about where these fossil fuel plants are that are mostly burning oil and sometimes natural gas, you've got millions and millions of people breathing that in down in New York City. Because you heard it's about 80% fossil fuel. So when you hear us talking from the state about fair and equitable, this is a huge benefit with renewable energy and bringing hydropower down from the north to the south, is that it relieves, makes the health conditions so much better in New York City. And then if you look at the Bronx, they have the highest asthma rates in the country. And so the respiratory illness there is responsible for many deaths and a lot of money. So when you talk about bringing power down from the north to the south, and there's a cost to it, but the benefits so far outweigh the costs.
Thank you. I think an important message here that we just heard is the important role of communities. And communities have an influence on clean energy in two ways. We just heard the very, very important benefit in communities because of clean air. And when we talk about clean energy, the benefits are not just for the climate, but they're also for all the other air pollutants and all the other environmental impacts that are associated with the extraction and transportation and processing of our fossil fuels. So climate is an important one, but the environmental benefits far outweigh that. So I know amongst you, there have been influences of communities on clean energy, both in terms of recognizing the benefits, as we just heard, the benefits to people in Bronx and Astoria, where my daughter lives. I would be very happy for her to have cleaner air. And so some communities recognize the benefits. Other communities, though, are swayed by other, I'll say, misinformation campaigns, and they are sort of NIMBY, not in my backyard types of communities. And so communities are really important in both ways. And so I just, really quickly, we could talk about this forever, I am sure, and I don't want to do that. But I do want to hear a little bit, maybe from all of you, about your experiences with communities, community acceptance, either positive or negative, and how that has influenced our ability to transition towards a cleaner energy future. Tyler, we start with you.
Yeah, so honestly, one of the best ways for people to really understand energy is to, I mean, this is a disruption that's happening. It's a whole new way of looking at things, and it begins with education from every level, both those integrating it and also those using it. There's a lot of education that needs to happen because there's new technology coming, there's new delivery methods, there's new production methods that are being used, and so a lot of times with education and change, we resist change, and I think it's really important that everybody understands that change is good in many ways. We need change right now to be able to accomplish some of the goals that we have.
Thank you. Peter, do you want to give us maybe, you've just mentioned the positive community interactions. Can you sum up Hydro-Quebec's negative community issues in 1 minute?
1 minute? Oh my God.
Maybe 2 minutes.
2 minutes. Well, I'm going to go very, very quickly.
Okay.
And there's a lot to talk about, so please see me after this if you're interested. I mean, Hydro-Quebec's been around for about a century, so there's a lot of community engagement over a century of existence. And the Champlain-Hudson Power Express has been in development for 10 years plus, almost 14 years actually. So in those 14 years, it's hard to kind of, bring it down to 2 minutes. There's a lot of acceptance in certain places. There's some reticence in others, and we're accepting at a base level that not everybody agrees with everybody, right? You have to respect. We heard that this morning from the Grand Chief. We're all here. We have to respect everyone's opinions. Then we started to drill down into facts, and I think that was the important thing. We went from community to community. This is 39 communities from the northern border here, the Canadian-U.S. border, to New York City, addressing all of the concerns of these communities and addressing them with facts. Right? And we did it with an open mind, right? So I think you have to do that. You have to go to where the people are, you have to meet, and you have to talk with them. You have to understand their perspective. You have to do it equitably. There had been concerns from First Nations, and we heard it from the Grand Chief. We have a wonderful partnership, and I think it was important what she said, is that yes, history, there are things that were done in the past, we need to recognize those, but we also need to advance and use positive examples like the Champlain and Hudson Power Express and build off of those, right? Because we all have a common goal at the end of the day. Then you had the river. This is going to go in the Hudson River. This is going to be buried in the Hudson River. A lot of people concerned about how is this technology going to work in the river. We went through 5+ years of permitting. Army Corps of Engineers. We worked with the Riverkeeper. We worked with DEC. We worked. So many years were taken to look at the technology, how it was going to be laid in the river. We've recently done testing in the river to show that there's not going to be any impacts on local water intakes, and that was actually a product of work with Hudson 7, which is a municipal water commission down in the Hudson Valley that said, we need to do these tests with you, we need to see your data, we need to work, and we did that with open arms. So we have to address everybody's concerns. No project is perfect. I don't think we should lie up here and say we're going to have a perfect project. Even the Champlain Hudson Power Express, for how wonderful it is and all the benefits it's going to have, is not a perfect project, but do we need to let perfection be the enemy of the good? So I'll stop there.
Thank you. So I want to move on to another topic. I do think that people need to understand these systems, and that's why we started with sort of an explanation of what the systems look like. But something that Doreen Harris said this morning, she's the head of NYSERDA, the New York State Energy Research and Development Authority. She said that there will be hundreds of thousands of jobs generated in the next decade or so to help to support New York State's clean energy future. And that's just New York State. When you multiply this like around the country and the globe, that's an awful lot of jobs. I'm an engineer, and I think when I talk technical, people think, oh, it's the engineers, right? The engineers are needed, and yes, we need engineers of all types to help support this clean energy future. So Ken and I work together at Clarkson on the engineering. But it is far, far, far greater than just the technical side. So I just wanted to ask each one of you, what do you see as the other workforce development and workforce opportunities that are going to be associated, the opportunities and the benefits for this clean energy future? David, do you want to start?
Yeah, sure. I mean, Doreen's right. There's going to be hundreds of thousands of green jobs generated here in New York State. And I used to be a solar developer as well. So as you said earlier, it's not just people turning wrenches and going out into a field and installing solar panels. It's sales and marketing teams, it's attorneys, it's accountants, it's analysts, it's engineers. It goes on and on as far as the vertical integration of jobs that happens. And I think it's going to be essential, that we train people here. I know NYSERDA has a very good workforce development program, and you could just Google it and look it up. But right now, just in the solar program I oversee, it's 5 megawatts and less, the smaller projects, smaller, but it could be like 30,000 solar panels small. But we have about 14,000 solar jobs just from this program in New York State. And what I really feel like is, we got to create an industry that's too big to fail, quite honestly. We got to create a lot of people. We talk about your first question about how do we get the community involved? Jobs, jobs, jobs. It's the same question and same answer, right? Does a project going into a specific community bring jobs there? Does it help low income and disadvantaged communities create new jobs and new territories at which they can work in the workforce? So I think jobs is extraordinarily important, and plus I hate to say it, but it gets political, and the moment someone wants to cut back on maybe advantages to renewable energy, the unions will come out, the job force will come out and say, no, you're killing our jobs. So I think too big to fail, allow people to transition from a particular industry in fossil fuel that's going away or minimizing, and allow them to be retrained and retooled as well to get into renewable energy.
Thank you. Peter, do you want to add anything about what sort of job opportunities, workforce development? It should just be on. I think
so we don't. Yeah, I mean, that perfect point to what David said. There's going to be lots of jobs out there. And again, for the younger people in the audience, it doesn't just mean engineering jobs. Sometimes, I mean, I went to school as well and not really good in math, not really good in science, and figured, like, what am I going to do if I want to get into clean energy? There's my job. There's stakeholder relations for a company. There's Basil's job, Basil Sagos, you know, he's a commissioner. So there's lots of different jobs. There's teachers. A lot of the work we've done in New York City is around buildings. So I think I'll just take a second. Each part of New York, since we're focusing on it, is going to have a different need in terms of their job force, right? We see that. We have a green economy fund as part of our project, the Champlain Hudson Power Express, as I said. So we said, how are we going to help these communities, especially in disadvantaged communities, get the training they need to be able to do these jobs? So it's a $40 million fund, and we said that's great to have that, but we need to understand what the needs are of the communities. So we put together an advisory board. And the advisory board represents the geography from the north all the way down the south. And quickly we found out that there were different needs in different areas. And I'll give an example. New York City, buildings, 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 right? 70% of the emissions, if not more, David could probably correct me, are coming from the building stock, right? So we know that the buildings are going to need to be upgraded, modernized, like we heard from Orta before, but on a massive scale in New York City. So what are the kinds of jobs that are in buildings? You know, yeah, we got engineers, but we got construction workers, the labor movement's very important down there. We have supers to take care of the buildings. We've got lots of different types of jobs that we're realizing that are very important. Installing heat pumps, another technology that could, you know, really help a building become more energy efficient, spend less money, and be cleaner. So we said, okay, New York City, that's very interesting. In the North Country, Plattsburgh, which is right, you know, across the border from Montreal in Canada, it's all about electrifying transportation in the transportation sector. And we're hearing, yeah, well, we want to train our community in the North Country to learn how to work on electric vehicles and promote electric vehicle technology. And in the Adirondacks will be a different example, and in the Hudson will be a different example. So we're going, again, to where the people are, as I said before, hearing what they do, what they want to do, and we're helping to train them that way. So there'll be all different types of jobs in this transition. And I agree with you, we got to make it too big to fail.
Ken, anything to add, or did we cover everything already?
Well, I just wanted to add one thing. I think, and because I'm an educator, I frame everything in that kind of teaching education. And a lot of people, you know, they hear about these technologies, and there's immediate, like what Tyler was saying, an adverse reaction, right? I mean, it's a change, it's not something. And if we can educate them to the benefits of what, instead of being something maybe that they don't like, what's a good example? Oh, I don't like to have wind turbines around here because my property value is going to go down, something like that, right? It impacts them directly. Instead, educate them as to what the opportunities are. And I think jobs is a really good one. You know, we've been very fortunate at Clarkson. We've had some good work on technology, and we decided to spin it out into a company. So we have a company now that makes small wind turbines, and we have 6 new jobs of people that have that kind of thing. And when people realize, and they turn it into an opportunity, instead of something that, you know, could impact them in a negative way, and that requires education. I mean, I've been asked to give talks in local communities around the North Country, and it is amazing. At first, you will go in there, and it's a very negative crowd, you know, and it's, you have to, if you start laying out things with data and not just opinions, but, you know, and in data in a way that Kurt Steiger said earlier that people can understand, then people start to think, well, wait a minute, if that, you know, and you get them thinking and you get them engaged, and that makes all the difference in the world. So I think, you know, that really, I know it kind of comes back to education again, but it really is education, whether it's at the state level, whether it's, you know, what's coming in from Canada, you know, Canada, those foreigners, from, you know, and it's really
Ken's
all about
Canadian,
education.
by the way, so.
I am Canadian, so I have to say that, that's true. But that's really what it boils down to, you know, why should I do this? What's in it for me, right? And people tend to think that way instead of what's in it for us. And so that just takes education.
Thank you. And so, yeah, so that education, but we also have to recognize that our current workforce needs to get educated. I just finished a year-long project with the New York Power Authority. We gave every one of their 2,200 employees a combination of live and virtual 10 hours of climate education. And so NIPA is a leader in that regard, recognizing the important role of education because they wanted their workforce to understand the whys, right? And the benefits and the opportunities and why they were being asked to do things a little bit differently. So education is really important. We're really glad that there's some youngsters in the audience here. I know this conversation might be a little over your head, but it's important. This is an important aspect of your future. So before we sort of finish up and run out of time for questions, we'd like to break now to ask if there are any questions, and then we'll come back and finish up our conversation. But we don't want to shortchange any question opportunities. I see one hand in the back, right?
Hello there. My name is Mark, and I work with FISU and a number of other international sports organizations, including World Aquatics, which is responsible for swimming and diving around the world. And this is a subject of immense interest to us at the moment because swimming pools, as you may be aware, consume a lot of gas when they're heated. And so I'm interested, but always we try and refer to practical examples. And so I'm interested to know that in New York, for example, whether your swimming pools tend to be gas heated and how you might be working to switch those out for heat pumps powered by clean hydro, for example, because we see that this is the kind of thing that is really the low-hanging fruit of decarbonization. Generally for municipalities, especially in Europe, throughout my country, the United Kingdom, swimming pool heating can represent up to 40% of a local authority's carbon emissions. And so replacing those with heat pumps is a great opportunity. And at the Paris 2024 Olympic Games, they're building just one permanent new venue, which is a swimming pool made out of wood, and it's got 5,000 square meters of solar on the roof, and it's got a heat pump, and it's got a battery, and the building will be net zero. So I'd be really interested to know how you think this kind of thing might work for you guys.
You know what's really funny is my first job in this industry was for solar pool heating. And I took a NAPCEP course, so I happen to know a little bit about what you're talking about. But yeah, the interesting part about heating pools is what I learned is it's the surface area in the wind at which takes the heat off the pool. And they said the best thing you could do is put a cover on at night because most Americans do not do that, and that would save you about 50% of the energy. And then on top of that, an air source heat pump. I was curious to know if they do make one specifically for pools or not, but it sounds like a really good idea.
Mark, I just want to congratulate you on thinking about the system. And that's really exactly what we need to do. And we talked a lot more on the supply, but that demand is what really helps us. One of the biggest challenges to our future electric grid is electrifying everything, right? All of a sudden, our electricity demand is going to go up substantially when we electrify things. So if you can couple your heat pump with your own solar and battery storage, then you're putting a whole lot less demand on the electric grid. And I would concur, and I think even in indoor pools, the number one thing to do is to put a cover on it whenever not in use. And I know then you've got operations and manual labor, and people are gonna complain about the effort that it's gonna take to do that, but that is even if there's not the wind, the indoor pools as well, the cover is really, really important because your air temperature is usually far less than the water temperature. All right, great question. Anyone else?
Hi, I'm curious what you all think about nuclear energy and its role in providing clean energy.
David, is that for you?
Yeah, I mean, it's a slight third rail, but I think we don't really plan on building any more new nuclear in New York State just because it's not cost competitive anymore. and getting through permitting and everything is very difficult. I think the reason why Indian Point was closed down is because, number one, it was old and wasn't very safe. But number two, you can't evacuate 6 to 8 million people in the time period you need to in case something goes wrong. So the nuclear that seems to be acceptable these days are when there could be a situation that you're able to safely evacuate that population surrounding that plant in time. And if that is not doable, then I am not for it, right? If it is doable, then maybe you could keep it running. I would prefer to have our power run by the wind and the sun and the water over nuclear, so I'd like to see it all get phased out, but I think we need to phase out as much nuclear as possible in more dense areas. It's my personal opinion.
We'll add some more opinions here. I am a nuclear advocate, and I would say until, I don't know, 5 or 8 years ago, I was not. But I believe it is a carbon-free energy system. But I totally agree with David that our current nuclear stock is not really tenable far into the future. But nuclear power plants can be small and modular. And in fact, they were in New York State's Clean Energy Plan of about, I don't know, a decade ago. They were an important, the small modular ones. Just think about nuclear submarines and ships. All those ships that are crossing the Atlantic Ocean, if they ran on small modular nuclear, just like submarines did, there would be far, the diesel tracks that they can see exactly where the ships go because of the air pollution that follows them. So I think there's a really important role for nuclear. But we have to figure out where to do it and where to do it safely. And perhaps saving our existing stock is not necessarily the right thing to do. I totally agree, building new nuclear power plants of the size of what we've done in the past is not the way to go. Smaller ones are safer because they're made in a factory, not constructed on site. And so I think we have to find the right role. Just like anything else, we need it all, and we need it soon. But we need to apply all of it to the right spot and the right conditions and the right set of ins and outs and supply and demand and transmission capacity. All of that has to fit together into like one big puzzle, and I think that's a big challenge.
I'm also of the same opinion that I think nuclear is a great technology, but the location near people poses a problem. However, at the university, we're always supposed to be thinking out of the box in the box. And we've talked about a lot of, and we don't have time to get into that here, but nuclear energy provides an incredible resource. If you think, you mentioned earlier that we may go from battery and even hydrogen. The use of nuclear energy in a remote location close to a water source could provide a tremendous amount of hydrogen that could then be transported to other places on the planet. So I think, to rule it out completely is not a good idea. And I think to think maybe in different ways in which we can use it could provide a lot of very interesting solutions, especially when we think about utility grade storage of energy for on-demand use.
Just a little follow-on to the nuclear. I was one of the expert witnesses in the closing down of Indian Point with regards to the EJ contention. I'm also a former Navy vet, so I am also familiar with those issues as well. So yes, an engineering solution, in fact, you can talk to the technology, but the issue also is waste and waste disposal. Also fuel source. And often when nuclear is considered, they treat that as an externality and focus only on the byproduct from the energy and the emissions from actually using it in the actual plant operation, but not of the other factors that need to be factored in. And then also the cost at the front end is heavily subsidized by the taxpayers, which is a big incentive for the earlier plants and even for those that are being called for online. So the question right now is that of investment from an economic side. It's not the best from an engineering cost factor ratio, the best investment, number one. Number two, siting and locations, right now, populations are significantly at risk, and right now where a lot of these aging plants are indigenous and communities of frontline communities of color, so they are uniquely at risk. But also the thing that I think that the engineers need to also put on the front end of the table in discussing the solution is the harvesting of uranium and mining of uranium. In fact, that you can't do a beltway around Denver, Colorado because of the tailing disposal, and also the waste disposal and the management of that. We're talking about half-life of hundreds of thousands of years in risk. And so the term clean has to be put in asterisks if you're not factoring in the waste disposal as well as the mining of uranium.
Thank you for that input. All right, we'll do one more question. All right, comment, whatever.
So I want to piggyback on that comment. My background is in land use management and land use, and communities are very outspoken about that. So I would just like some thoughts in terms of your experience working with the community, specifically around transmissions coming through, the concepts of putting the transmission lines underwater through the Hudson, but also the waste in nuclear that we just talked about. I've been living in the West and in New Mexico for a while, and it's the dumping ground for our nation's waste and transmission lines. And I can tell you, the local people are not real happy about it, and you can talk till the cows come home, literally, being a ranching state. And this is a huge concern, and part of the storytelling and part of the concern is with these sustenance and subsistence living states and rural communities where all of the transmission, the waste, and all of that's having a very negative economic impact, and it's a huge concern.
All right, we have 2 minutes to wrap up. Peter, do you want to take that one?
Yeah, sure. I mean, I can take it. The transmission line, and we could talk after this. I have more than 2 minutes if you want. So this transmission line is going to go along existing rights of way, so along railroad tracks or in the river. Again, this is a multi-year process of stakeholder engagement. And the good thing about this is as we look from the very beginning, the first plans for this transmission line, it actually looks a lot different. And why does it look a lot different? It's because of the input from the community boards, from the local communities, from the authorities themselves. So we refined, we iterated, we made it better. The line itself, when it's in the water, is providing a lot of tax benefits right back to the very communities that don't have to actually spend any services to upkeep this piece of technology. It's buried under the river, yet there's going to be money going back to the communities. So there's a lot of ways for the communities to benefit from this. We got around the NIMBY problem we talked about before. You know, I like to hear people say YIMBY now, right? Yes, in my backyard. I mean, this line is out of sight, out of mind. So we're very, this is specific to this project. I understand your comment about other types of projects, but what I can say about this, it was this multi-year process, this iterative process of refining the transmission line and making it as suitable as possible to the community. And we went through a very extensive process of public engagement and comments at the state level. So I felt it was very healthy the way it was done in New York State. I know we're talking about New York State. There might be other places where you say, hey, I can get a transmission line built in a year, but it doesn't have the same type of process that's involved. So I think it was healthy to have this process. I think there's a balance in the process as well. Sometimes we might have redundancies in certain processes that make things longer, right? So we went back to your original comment about we have to go fast. Mother Nature's not waiting for us. So I think as we walk away from different parts of the world, we look at our own countries and the way that we function. I think we need to look at speed as being important, but we also have to definitely take into consideration local communities, listening, working together, and trying to get the best project as possible.
All right, well, I'm just going to wrap up really quickly here, and I want to reiterate a point that both Aaron and Louise made, and that is that we have been talking a lot about New York State. New York State is not, it's a geopolitical boundary. We have environmental boundaries that are very, very different, and we have a country and we have a world that we have to exist in, and whatever New York State does cannot but we can't put a boundary around New York State. And I have to admit, the biggest evolution in my academic background came from when I was at a California conference talking about their gasoline sources when they were going from MTBE to ethanol in their gasoline. And so this was in the mid-90s. And I was so frustrated that they put a political boundary about California. All they cared about was what happened to California. They did not care what happened to the Midwest when they grew corn with lots of fertilizer. So I am guilty as charged. We have to make sure that whatever we think about in these solutions, that yes, we can focus, we can talk about one state, but we have to put that in the context of the country and the world, and both the benefits, which I think there are huge benefits, and reducing of risks if we can go towards a clean energy future, outweigh the risk of climate. And that's truly a global issue. But we cannot forsake especially marginalized communities in doing that within the state or beyond. So unless if anybody has anything else, I think we are out of time. All set? Thank you all, Tyler, David, Ken, and Peter.
And let's give Dr. Susan Powers and his panel another big round of applause for an excellent discussion. Thank you. Great job. Hold your step, please. You did great.